All right, folks, it's Bass Action, back in action here. In this video, we are going to do a quick review related to arc length, and then we are going to develop the formula for the area of a circle, and then at the very bottom of our page, we are going to look at some special shaded regions in terms of circles. Okay, we'll use those for other things later, but for right now, that's what we're going to focus on. Okay, so up here at the top, let's just do a very quick review. I am going to go through this fairly quickly since this is review. When we do arc length, what we want to first remember is that there's no M, okay? Because there is not an M in the front of that arc name, we know that we want the actual length around the circle. Because this arc has been named with 3 letters, it tells us that we need to go this long way, that's more than half the circle around the circle. We are not just going the short way, that would be less than 180. Now, since we don't know currently the measure of this area, this angle here is 40, so we can automatically then fill in that the remaining portion of the circle is 220 degrees. Now, in terms of our 2 methods, remember, this is a choose your method. You are not going to do both of these. The first option to find the arc length is based on this definition. So we're going to use our arc measure over 360. So that's going to be our 220 over 360. And we're going to multiply that by the circumference of the circle. We can see that our radius is 10, so our circumference is going to be 20 pi. Over here on the arc, on the proportion method, we would still take our arc measure, and that would be our still 220 over 360. And that's going to be equal to the arc length that we don't know of, we'll call it x, over the circumference of 20 pi. Now, this is where we talked about being able to work with our fractions. So I'm going to come back over here to our definition, give you a couple reminders. We can certainly reduce those by 0. I can reduce my 22 over 36 to 11 over 18. I can also reduce my 18 and my 20 to become 9 and 10. So when I then multiply my fractions straight across here, I'm going to get 110 pi over 9, and that would be inches. Over here, we can do some similar reducing. I'm going to reduce those zeros again. I'm still going to reduce this to an 11 and an 18 because they both divide by 2. When I cross multiply here though, I'm going to remember that I'm going to have my 18x, but I don't actually want to multiply that 11 and that 20 pi. I want to leave that separate, so it's going to be easier for me to see how this is going to reduce when I divide by that 18. It's going to make this a lot easier to follow that the 18 becomes 9 and the 20 becomes 10. So that's going to be an easier method to get us to our final answer of the 110 pi over 9. Okay, so just that quick review there because we will be using that again later in this video. Now, area of a circle, we've certainly done the area of a circle before, we've just never developed it. So now we want to look at where the formula comes from. So we know that the formula for area of a circle is pi r squared, okay? What you can see here is I've taken this circle and I've colored it, okay? I took half the circle and I colored it one color and the bottom half another. You'll notice that I have it divided into 8 nice pieces. Now, what I did over here, and you can kind of pause the video and draw this picture, is I essentially took the 4 triangles or pieces of the circle and I drew them here. Now, I did draw these as nice straight flat sides, even though we understand that from our actual circle these would be curved. What we're trying to imagine is that if I cut this circle into smaller and smaller pieces, then the smaller the piece that I make this, the flatter this side is going to become, and it will eventually, if I make them very, very tiny, it would eventually create essentially a parallelogram, okay? So I've got my 4 pieces here are my 4 purple ones, and then my 4 red ones become my 4 red ones. Now, we understand that the area of a parallelogram is going to be base times height. So the base of this parallelogram here is half of the circumference of my circle, or half the perimeter. There's a couple ways we can think about this, okay? So half my perimeter would be that side. And then the height of this parallelogram, well, the height is actually going to be the radius of the circle, because remember, we're imagining that we're just going from the center out to the circle, and this is effectively flat. So the height is going to be the radius. So now, if I fill this in, my base was 1/2 my perimeter, my height is my radius. I know that the perimeter of my circle is the circumference, so that's going to become 2 pi r, and then I still have the radius there. Now I can see that this half and this 2 cancel, and then right here is going to get us our pi r squared. So that is where our pi r squared formula is coming from. All right, the last thing that we're going to look at are 3 special types of shaded regions, okay? The first one is virtually identical to what we did up at the top, except for it's a shaded region instead of the circumference of a circle. So this first shaded region looks like it's kind of this whole piece of the pie, and it is called a sector, okay? A sector is a whole shaded chunk of the circle, okay? There's not a way to name it. We just know that this is called a sector. We can call this portion here the minor sector for this whole circle, and I would call this portion over here the major sector, okay? So I have my minor sector and my major sector. To find the area of the shaded region, we're going to have the exact same 2 options that we had from up above. I can first think of this as a portion of the area. So the portion that I'm thinking here, this is going to be 120 degrees. So I would think 120 out of 360 degrees of the circle. And then the area of the circle, my radius is 6, so the area is going to be 36 pi. Now, if you're using this method, this is more of a definition method, we can see that these would reduce. This would become 1/3. My 3 is going to divide into my 36, so I can reduce again. And my area for this shaded region, this sector, this minor sector, would be 12 pi, and it's an area now, so it's inches squared. Now, some of you liked from up above, you liked that proportion method better, and you would then set it up very similarly. You would still say your portion, your 120 out of 360. You would still say that you don't know the area of this region. Now for your whole, instead of using circumference that we did up here, we just replace that with area. So same exact idea. So I'm going to fill in my 36 pi. Again, I can reduce this. This is going to become a 1/3. If I solve this cross multiplying, I'm still going to get 12 pi inches squared. Okay, so 2 methods for that one. The next thing that we're going to look at is called a segment of a circle, and this very specific language, segment of a circle, is not a straight object. A segment of a circle is a shaded region. It's specifically, and it maybe yours doesn't show up super well, but is specifically this tiny little space that is going to be between a chord and the circle. So it's this shaded spot between the chord and the circle. Now, to find the area for a segment of a circle, what we are going to do is we are going to find the area of the minor sector, and then we're going to subtract the triangle. So let's take a look at those 2 regions that I've got going on here. My minor sector is going to be this portion right here. So the minor sector, just thinking back to what we just did on the last problem, we can see that since this is 90 degrees, we are going to actually just have 1/4 of the circle. And the area of my circle, since this is 8, the area of my circle is going to be 64 pi. So the minor sector for this picture right here is going to be 16 pi. Now we also need to find the area of the triangle. So we're going to subtract the area of this triangle right here. Now that triangle is a right triangle in this case. So it won't always be a right triangle, but this one is a right triangle, which means both of these radii are 8, and this is a nice right angle. So that area is going to be 1/2 8 times 8. So the area of the triangle is going to be 32. So our area for this segment is 16 pi minus 32, and it's an area, so we're going to label this as inches squared. Okay, so the minor sector, it looks just like this process, and then the area of our triangle, so we're just going to think back to how we do area of a triangle. My last one that I'm going to look at is called an annulus, and I just like to think of this as a ring, okay? This is really just going to be a ring. It's not always going to be 2 circles, okay? Sometimes the outer shape will be a square, some other kind of polygon, but for right now we're just going to focus on the 2 circles that I have here. So all I need to do on this one is do the area of the big circle minus the area of the small circle. So this one's going to be pretty straightforward. The area of my big circle, I can see that its radius is 20, so its area is 400 pi. The area of my small circle, its radius is 17. Its area then is going to be 289 pi. These are like terms, so we can actually just subtract them and get our final answer of 111 pi. And we don't have a unit this time, so we're going to say units squared. Okay? Now we are going to do even more variations of these, but these are the 3 basic ones of our shaded regions, and everything kind of comes back to some version of this.